This video is on periodic trends exercises. Let's compare these periodic trends against fluorine and chlorine. Which one has the greatest atomic radius? Atomic radius, if this was a periodic table, increases in this direction because of increasing electron shell size. That's because fluorine and chlorine have approximately equal effective nuclear charge. Chlorine has the greater atomic radius because it is just one electron shell larger, and so the electrons are just further away from the nucleus. In terms of electronegativity and all the other characteristics, and other characteristics like ionization energy, on the periodic table they increase going this way. So fluorine would be the more electronegative, which is the tendency to pull on the electrons when within a molecule, because fluorine has a lot of protons in its nucleus per number of electrons, which don't really shield each other that much, and so the effective nuclear charge is rather large, and they're rather close to the nucleus too, because they're only within a 2s electron shell too, and so the nucleus pulls on the electrons a lot, and thus similarly fluorine has the greater ionization energy. Ionization energy is the energy it takes to remove one electron, and for fluorine that energy will be very great because the electronegativity is so great, like the nucleus pulls on the electrons so much that it would take a lot of energy in order to remove one. Metallic character increases in the same direction that the atomic radius does, and even though both fluorine and chlorine are very, very much nonmetals, technically chlorine would have the greater metallic character. Let's try that again with a different set of atoms. For example, aluminum and silicon. So in this case, aluminum would have the greater atomic radius because its effective nuclear charge is smaller, and thus it pulls on its electrons less, and then and thus the electrons are allowed to exist further away from the nucleus, resulting in a larger radius, whereas and this effect is much greater than the additional electron repulsion that results from adding one more electron. Similarly, in this case, silicon has the slightly greater electronegativity because of its greater effective nuclear charge, so it pulls on its electrons more, and is thus more likely to hold them tighter within a molecule. And similarly, thus ionization energy is also greater for silicon because it pulls on its electrons more. It'll take more energy in order to remove one. And thus, similarly, due to the nature of the trends, aluminum will have the greater metallic character because it's a metal. And that's all. Thanks for watching.